Hey awesome coders, this is Mr. Wagner. We are on pong5. Okay, so as you see up here, I have pong4 code up, so I'm going to do a file save as, and I'm going to call this pong5. And let's go ahead and begin. To recap, we're going to run the module, and basically we have this ball that is now moving, and that's great, but it goes right off the screen. In pong5, the plan for this particular one is we are going to see what we can do to bounce the ball, okay, to bounce the ball, and we're going to see what we can do there. Now the first thing I want to show you is if I were to come down here on lines 38 and 39 and I were to change, say, change this +1 to a -1, okay? So instead of ball x equals ball x +1, it's ball x -1. So I'm going from 100 to 99 to 98. So let's see what that does in terms of this code, okay? And notice that, well, I don't know if you got to see that fast enough. Let's try that again. The ball is basically moving diagonally down towards the left, or in my situation, down towards the left. And that's just because I changed that from a +1 to a -1. Okay, now what we're going to do here is we are going to leverage the fact that if I change it from a plus to a minus, I can make it go the opposite direction, okay? And in order to do that, we need to introduce a couple new variables. And the two variables that we are going to introduce are right here. We're going to put these at line 16 and 17. We are going to call this dx equals 1, and we're going to call one dy equals 1. Okay. And what you'll find out is coders from all over the world use dx and dy to say the change in x or the change in y. So dx means the change in x, dy is the change in y. And if any of you are in high school and you're taking calculus or something, I am sure that your calculus teacher is going to love you because it says dx and dy and you got to use them in computer science. Now, do not let calculus freak you out at all on this, because there's no calculus involved. It's just a variable called dx, a variable called dy, and what we're going to be doing is we are going to be using that dx and dy, and we're going to be changing it from a 1 to a -1 depending on if we need the ball to be going forward, backwards, left, right, up, down, etc. Okay? So let's see what we can do here. This is actually really pretty cool in my opinion. Okay, so we have dx dy, and then down here on line 40 and 41, instead of saying ball x equals ball x -1, I'm going to say ball x equals ball x plus dx, and then 41 is going to be ball y equals ball y plus dy. Okay, now notice that dx and dy are just 1, okay? I never changed them anywhere in here, okay? So when I run, it should just make the ball, you know, sort of go in that diagonal like we've been doing. Yeah, we're still on pong5. Okay, so there goes the ball, right? Okay, so now notice how the ball sort of hits this bottom line first, okay? Now, the x coordinates go across and the y coordinates go down, okay? X coordinates go across, y coordinates go down. And remember, 0, 0 is up here at that upper left-hand corner, okay? So we'll take a look at this. Now, what we're going to say here is we're going to put an if-then statement in here. And let's try this. We are going to say if the ball y is greater than 600. Okay, so the ball y is all the way at the bottom of the window. Okay, then we are going to notice how I hit colon after that if, and it automatically scooched that over. We're going to say dy equals dy times minus 1. Okay, now I want to break this down a little bit. So ball y is basically the y coordinate of the ball. So the y is going all the way down, and we're saying it's greater than 600, so it's at the bottom of the screen, right? That's what greater than sign means. Okay, just like math, okay, greater than sign. If that's the case, then we are taking we're creating the new value of y, dy, the change in y, is going to be the old value of the change in y times minus 1. So in other words, if it's 1, then 1 times minus 1 is going to be minus 1. And if it's minus 1, then, you know, two negatives multiplied together make a positive. So if it's negative 1, it's going to become positive 1. If it's positive 1, it's going to become negative 1. Okay? You may have to pause the video and just sort of think about that a little bit, or maybe just watch some more of this because I'm going to be massaging this little bit of code here to make it even a little bit more clear. Okay? So let's run this. Let's see what we get here. Run. Okay, so here goes. We're going to watch that ball. And notice how it bounced off of that, but then it just kept going. Okay, so just kept going. So let's close that down. And let's put a command in here for the ball X to see if ball X is greater than 800. Remember, 800 is the width of our screen. Then we're going to say dx equals dx times negative 1. Okay. So we sort of did these a little bit backwards, just because it was falling off the bottom of the screen first. Okay, but let's go ahead and run this. Here we go. And we should get a bounce here and then a bounce here. It's almost like pool, isn't it? So there's the bounce. There's the bounce here. Now at this point, dx and dy are both negative. Okay, so let's close that. Now, here I'm going to show you something that's kind of cool. And I'm going to put this, I'm going to put here, if ball y is less than 0. Okay, less than 0. In other words, the ball y has now gone off the screen. It's like negative 1, negative 5, negative whatever. Then I'm going to say dy equals dy times negative 1, okay? So let's hit run on that one, and you will see we're gonna watch it move. It's kind of fun to watch these things, okay? So there's the first bounce, there's the second bounce, and this dy should bounce there, and then this one will probably go right off the screen. And sure enough, it did. So let's go ahead and close. And basically, we haven't accounted for the case where ball X is less than 0. So we're going to say, we're going to put this if here. If ball X is less than 0, then, that colon kind of means then, dx equals dx times minus 1. Okay. And you know what? Remember how I said this time sleep here? If I increase that to like 0.01, So we're going to sleep less amount of time. That should speed the ball up a little bit. So let's run it and just see what we get. Okay, yeah, the ball's moving a little bit faster here. Bing, 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 bing. Kind of cool. It just sits there and bounces around. And if I were to like go away for a cup of coffee or something, it'd still be bouncing by the time I got home. All right, so that's it. Let's go ahead and close that. And I want you to just take a peek at, say, like line 44, 45, 46, 47, and I want you to notice that line 45 and line 47 are exactly the same. Okay, meaning we want to change, we want to negate whatever dy is if we are greater than 600 or we're less than this, right? Now, did you notice how in my natural language I said, well, we need to negate it if this or that, okay? Now, the beauty of computer science is we do have the word or in here, and I can do that. I'm going to put if the ball y is greater than 600 or ball y is less than 0, then we're going to do that. And now I can actually get rid of this line 46 and 47. Now just so we, I'm just going to comment them out because I want to sort of leave them there so you sort of remember that, you know, we were looking at all 4 different cases. Okay, so ball y greater than 600, in other words, we're at the edge of the wall, or less than 0, we're at the edge of that wall. Take that back. We're either at the floor or at the ceiling because we're dealing with y. Then we're going to negate the dy. Okay, and we're going to do the same thing over here with ball x, or ball x less than 0. And we'll go ahead and put pound signs here, right? So now we have these nice clean little code. Run, we're going to run the module and we're going to hit OK. And now our beautiful little ball should be bouncing all over the place. Bing, 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 bing. All right, so let's close that. I think we've made some really good progress here. We are, oh my gosh, look at this. I should have been updating this along the way. We'll make that code pong5. Okay. Very good. So line 44 through 52. Hopefully they make sense as to what we're doing. And I'm going to go ahead and close this window, and then we'll do Pong 6 next. All right, see you.